Okay, so this will go in your notes for section 5.1 and operations with polynomials, and I think you'll find a lot of this is some review of your Algebra 1. And like I said, this will be good for any of you that are thinking about that ACT test to go back and review. First, they define to simplify an expression containing powers means to rewrite it without parentheses, and I'm just going to use the symbol for parentheses, without parentheses or without negative exponents. Am I right that you probably, did you do any negative exponents in Algebra 1? Or I would guess you probably did not see negative exponents in Algebra 1. So this will probably be the first day for that. We're going to review laws of exponents. And you want to learn these because the laws of logarithms down the road will parallel these. So the laws of exponents for any, use a double bar R for real numbers. For any real numbers A, B, and X and Y, those are real numbers. So that means they can be rational or irrational. They just can't be imaginary. Okay, and integers m and n. So m and n have to be integers. And remember, when we talk about integers, we're talking about the set 0, 1, 2, 3, dot, 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 and -1, -2, -3. So can m or n be like 1/2? No. Or 3/4? No. Square root of 2? No. Okay? Okay, so the rules, the laws of exponents. First one. A to the n power times a to the n power. When you multiply monomials and the bases are the same, okay, you add the exponents. So it's a to the m plus n power. Okay, so example, if I had an x to the third times an x to the second, if those bases are the same, it stays an x and it's x to the fifth power. Okay, you can always go back to the long way. The long way would be to write this out. X to the third means x times x times x. X to the second means x times x. I mean, you can always go back to that if you're not sure. Okay. Another example, another law. A to the n power divided by a to the n power. The bases are the same, and you're dividing the monomials. Subtract them, so it's a to the m minus n power. Okay, so if I had x to the fifth divided by x to the second, subtract them, x to the 5 minus 2 would be x to the third. Or, sorry, yeah, that's right. X to the 5 minus 2 would be x to the third. If I said, turn it around, if I said x to the second divided by x to the fifth, you still say x to the 2 minus 5 would be x to the -3 power. A negative exponent, if you want to write that with, because it says up here, when you simplify it, can you have any negative exponents? No. So if it's a negative exponent, to rewrite it, you just rewrite it, move it down to the denominator and make it a positive exponent. if it's a negative exponent down in the denominator, move it up. And that's coming on the next couple of rules. Okay, third one. A to the m power and raise that to the m power. When you raise a power to a power, multiply them. A to the mn. So if I had x to the second and raise it to the third power, raise a power to a power would be x to the sixth. Okay, now this is actually the definition we should have had up above here. It's a to the negative n power. If you have a negative exponent, you move it down. So it'd be 1 over a to the n power. If you have a negative exponent down, so if you had a to the negative n down, to make it positive, you just move it up. Don't make that hard. Okay, so you move that up. So if I had 5 to the negative 2 power, that's 1 over 5 to the second, which would be 1/25. Okay, if I had 1 over 5 to the negative 2 power, to make it positive, you just move it up to the numerator, change it to a positive exponent, and that'd be 25. So these are two separate problems. Okay, a negative exponent, just move it and make it up or down and make it positive. Okay. Couple more examples, like if I have x, y, and raise that to the m power, that m applies to both of them. So this is like x to the first and y to the first. So you take the x to the first and raise it to the m power is x to the m, and y to the first and raise that to the m power would be y to the m. And that's your final answer. If they had x, y, and raise that to the third, then that'd be x to the third, y to the third. That exponent on the outside of the parentheses applies to both of them on the inside. If you have, let's say I have 2a to the third, b to the fourth, and raise that to the second power. Okay, so you have to simplify the number in front first. 2 squared would be 4. Raise a power to a power, a to the third, and raise that to the second would be a to the sixth, and then b to the eighth. So that 2 on the outside applies to the coefficient, okay, and to the numbers and exponents inside there. There we go. Let's do one more of those. Let's do 3a to the fifth, b to the second, and raise that to the third power. So 3 to the third power, 27. 3 to the third, 3 times 3 times 3 is 27. A to the, raise a power to a power, multiplying. A to the 15th, b to the 6th. So the 3 to the third power, 3 times 3 times 3 would be 27. And then raise a power to a power, a to the 5th, raise that to the third, multiply it. Okay? Okay, next rule. So you have x divided by y, and that is all to the m power. That m applies to both of them inside. So it's like you're raising this one, so it'd be x to the m over y to the m. Okay, and your y cannot be 0 because you can't have division by 0. If, and this is a prime, this would be a prime ACT type question. If I have x, y to the negative m power, I can work this the long way. I can put that whole thing, y over m, down in the denominator. Okay? But you can just invert it. Invert it, and you'd have y over x to the m power. Okay? And that is y to the m I did something wrong in my notes. Okay, and gosh darn it. Right, just invert it, and make it a positive exponent, and then that applies to both of them. Okay? So if I gave you 3/4 to the negative 2 power, the shortcut is invert the fraction and make it a positive exponent. So that'd be 16/9. And you could work it the long way, but it just takes the fraction and inverts it. Okay, and then rule 7. We're getting to the end. A to the 0 power? 1. The only one is 0 to the 0 power is undefined. Everything else to the 0 power is equal to 1. So like if I give you x to the 0 power, it's 1. 9 to the 0 power is 1. It's just defined that way. By definition, anything, because you think of anything, what's anything to the first power? Itself. Yeah, so if you start going, like if I said 5 to the first power is 5. 5 to the second power is 25. Now if I start going the other way, 5 to the 0 power is 1. 5 to the negative 1 is 1/5. Goes the other way. 5, yeah.
There's just nothing there. It should be
Okay. 5 to the first power would be 5. Okay. Okay, now I want to go through some examples using all these rules. Okay, so you have something to go by. Okay, they will just say simplify. When they say simplify, okay, you got to know what that means. Look back up here. Simplify, it contains no parentheses and no negative exponents. Okay, so they will say in the direction simplify and means rewrite it without parentheses or negative exponents. Okay, so example. So I give you the quantity negative 2x to the third y times the quantity negative 5xy to the fourth. Now you're multiplying. First you have to look and see if there's any exponents on the outside. No. Now multiply the coefficients. Negative 2 times negative 5, 10. You're multiplying monomials, so what do you do with the exponents? Add them. So x to the third and x to the first, x to the fourth, y to the fifth. No negative exponents, no parentheses. We're good. Okay? Stop me if you have a question. Parentheses 3a to the fifth times c to the negative 2 times the quantity negative 2a to the negative 4b to the third. Multiply, there's nothing on the outside. Multiply the coefficients. 3 times negative 2? Negative 6. A to the first, right? Or just A. B to the third. C to the negative 6. The only one that goes down.
Why is it C to the negative? We need C to the negative second.
Ooh, wait a minute. Sorry, I was looking at that. A. Sorry, that's my fault. C to the negative 2, right? The only one that goes down is that C. Okay, so it's going to, the negative 6ab to the third stays up. All over c squared. Okay? Everybody okay with that? Okay. The quantity, negative 3c to the second, d to the fifth, close the parentheses and raise it to the third power. Negative 3 to the third power. Negative 27. Negative 3 times negative 3 times negative 3. C to the 6, d to the 15. Okay? Raise a power to a power, you multiply them. Just simplifying it. Negative 2a, and it's all over c squared And that quantity's to the fifth.
That's
Negative 2 to the fifth power.
can't.
No, this one's not, you don't invert it, because it's not a negative exponent on the outside. But what's a negative 2 times a negative 2 times a negative 2 times a negative 2? Positive or negative? Negative. So it's negative 32, a to the fifth, c to the 10th. Are we good? No negative exponents, no parentheses. We're good. If it was a negative exponent on the outside, then I would invert it. Okay. 420 to the 0 power. 1. 420 to the 0 power is 1. Okay. Okay, here you go, Duncan. 3/4 to the negative 2 power. Invert it and make it a positive exponent. 16/9, right? Okay, number 7. Up in the numerator, 15n to the second divided by 25n to the 10th. Reduce your fractions. 15 over 25. 3/5 into the, I can do this a couple ways. I could do 3/5 into the negative 8, and what's that negative 8 do? Moves it down, so 3 over 5 into the 8. Okay? Okay? If you're, another way to say that, look at that problem. If your larger exponent's on the bottom, that part of your answer is going to be on the bottom. Okay, 2 more. Quantity 7a to the negative 3 times the quantity negative 4a to the 5th x to the 8 times the quantity negative 2a to the negative 9 x to the 10. Anything on the outside?
No.
And really, those of you like me with visual problems, you got to really look for those exponents on the outside. Okay, there's nothing there. Multiply the numbers in front. 7 times the negative 4. Negative 28 times the negative 2. Positive or negative? Positive 56. A to the
Negative 11.
Negative 7. X to the 18th. Which one's going to go down? So it'd be 56 x to the 18th over a to the 7th. Okay? Last one. 3a to the 3rd over b to the 4th, and that is all to the 2nd. 3 to the 2nd, 9a to the 6th, b to the 8th, divided by b to the 8th. Okay, questions? Can't reduce it anymore. Okay? Okay.
Oh, that's right. Yeah. Okay. No problem.